Hello. So, thank you for coming to another Flutter meetup from the GDG Barcelona. I want to thank, first of all, I want to thank Stuart for providing the sponsorship and the place today, and also the talk. Yeah, thank you. As there are all faces, some new faces. Some of the faces may remember that we used to have a monthly meetup of Flutter, that we've kind of stopped that because there were enough material, like in talks, people speaking and presenting things. So if you have something, if you are doing something in Flutter, some pet project, working doing something at work, and you think it's interesting, please come and talk to us, and we can schedule the following Flutter meetup, because right now there are no more one scheduled. Except on the 11th of December, we are doing a live streaming of Flutter Interact, which is the event where Google will introduce whatever they do, because we don't know. So again, thank you for coming, and I'm passing the microphone to Loki.
Thank you very much. Hi everybody, my name is Loki. I'm CTO at Stuart. I hadn't actually prepared to really speak tonight, but the guys asked me to give a quick sort of presentation about what Stuart is. So I'm going to go very quickly, I won't take too much time, but the idea is to give you guys a bit of context about Stuart as a company, the engineering department. Yeah, let's go old school. No, even old school doesn't work. Maybe if we click here. Yeah, that'll work. Super old school. Okay, so I'm just going to take a couple of minutes. I won't take very long because I know that we're all here to talk about Flutter. But I think it helps to just have a bit of an idea about what Stuart is, have a bit of context so you understand more about the decisions that were made by the team to choose Flutter. So I'm going to talk about three things really quickly. One, I'm going to talk about Stuart, what Stuart does, because chances are you guys don't know what Stuart is or what we do. I'm going to talk about very quickly Stuart Engineering, the team as a whole. And then I'm going to talk about Stuart Engineering Meetups, okay, and why we're doing these. This is part of an overall kind of initiative that we have. So Stuart is essentially a delivery company, okay? This is our mission. Logistics for a sustainable world, shared, efficient, reliable, okay? So what that actually means is we do delivery, and especially we do last mile delivery. That means we do delivery inside cities, okay? We don't do delivery between cities, we don't do delivery between countries or planets, inside cities, but maybe that's going to change one day in the future. So we care a lot about having a sustainable future for this world, and it's actually one of the key metrics that we have as a company is reducing carbon emissions, okay? So that's why it's about a sustainable world. How do we do that? We do that by sharing deliveries. So if you group deliveries as much as possible between drivers, people who are doing deliveries, the number of deliveries the number of people who are actually doing that and the number of people who are emitting carbons goes down much more, okay? And then traditionally in the logistics sector, we don't do that nearly as much as we should. Second of all, efficiency. There's huge amounts of efficiency loss in the traditional logistics sector, and we make big efforts to be as efficient as possible. That also means that our prices are lower and our drivers are happier because they are more effective and therefore they earn more money. And then of course reliable. If you're not a reliable logistics provider, then you're not a good one, and we want to be the best, so reliable is important, okay? Now, a few words about Stuart. We operate in three main kind of verticals. So food, fast food is one of the most important ones. We do delivery for clients like KFC, Pizza Hut, Burger King, McDonald's, also for marketplaces like Just Eat, Restoin. obviously heard a lot of those names before, but you probably haven't actually seen Stuart. That's because we're a B2B company, okay? And we're not that visible. We're definitely not a B2C company, so that's why most people haven't really heard of us. But the reality is that Stuart is an extremely fast growing company. When I joined 3 years ago, no, actually 4 years ago now almost, we were doing about 500 deliveries a day. Okay, today we do about 150,000 deliveries a day. So the growth has been phenomenal. And in the last year, we've done almost about 5x growth, a little bit more actually. And in the last 2 years, we've done about 10x growth. Okay, so the project which we've been working on, we've been doing a big migration of our platform, which is sort of the catalyst for the particular project which we're going to talk about tonight, is to help us to go forward in the future. But when we started that project, and where we are right now, just finishing that project, we've had 10x growth in the business, okay? So what's interesting is that a company that is growing as much as we are, that is getting as big as we are right now, normally in the startup space, everybody knows about it. But because we're B2B, because we're kind of hidden, because we're in logistics, we're kind of not very well known, which is not something which I don't mind that we're not very well known, but that's just sort of a bit of a context. Okay, so let's talk about Stuart Engineering very quickly. So today we're 65 engineers. It's always hard to keep count because the number's going up quite quickly. We're growing very, very fast. We're mostly in Spain. This is the biggest concentration of developers that we have in the engineering team on this floor right here. But we're also in France, and we have a large amount of remote guys who are spread out all over Europe. And we have no particular preference for remote or local. It kind of really depends on the team. But for example, we have one team, our back-end team, who's almost 100% remote. So we have a mix. There are about 10 different teams in the engineering department. And the mobile team is one of the teams who's going to present to you tonight, one of those particular teams. But we have front end, we have back end, we have QA, we have data engineering, we have data science, we have BI, we have DevOps. I've probably forgotten some, Agile. We have quite a lot. And what is important is that we're doubling the team over the next 12 months. The growth forecasts that we have for Stuart as a business are much more than we've had in the past 2 years. So in order to be able to scale up, we're scaling up the team as well. So that's going to be a very exciting and challenging future for us. So Stuart Engineering Meetups. Okay, so this is sort of more about what we're doing here. We decided earlier in this year that we wanted to start to have much more of an impact on the community. So what that involves is publishing more open source. Inside Stuart, as it's a logistics company, there is a lot of very, very complex data science and software engineering problems that we deal with. And a result of some of those is some really, really cool stuff. So we're starting to open source stuff more and more. And that's one of our initiatives. Another one is sharing our knowledge. So sharing the knowledge that we have here inside at Stuart, which is a result of all the work we've been doing. Tonight is an example of that. And another one is facilitating the community and helping with that. So using the spaces that we have in Paris and here in Barcelona to host meetups, which is what we're doing here tonight. This photo you can see here is our office in Paris, where we have at least two meetups a month. And we hope to be doing more here in Barcelona. So that's an overview of Stuart and what the team's like. So I'm going to pass it over to Sergi to talk about Flutter.
So thanks, Lucky. So Flutter, you know Flutter, right? So this is the agenda that we will be following today. We'll wave at each other, which we probably did already. We'll give you some context of why we built a new app from scratch, and then why using Flutter instead of the native approach. Then it was not easy to share our experience, and we decided to divide it in like 5 categories, which is the single code base from the point of view from Android developer to Flutter, the same from iOS to Flutter, then the current app architecture in Dart, And then the issues that we faced. We faced a lot of issues, and we will only show you the highlights of them. Then we'll show you a quick demo of the current courier application, which is the one the couriers are using in the streets. The QA team is also presenting a little bit, which we somehow consider them in the mobile team because we cannot live without them. And then we have a Q&A session, that can last forever because we'll have beers and pizzas being delivered, not by Stuart, by the way, but we'll be into that. So welcome everyone, thank you for coming. Okay, this is the highest fidelity diagram that you can find in the internet. This is Stuart when I joined 5 years ago. The model was a pickup and a drop-off. You could only request a driver or a courier to pick up something somewhere and to drop what was picked at the pickup place, right? Quite simple. That was 5 years ago. With the same database model, we were able to optimize it in a way that the courier could pick up multiple packages in one single place and drop off in different places. So imagine you pick up 5 pizza boxes and then you deliver them to 4 different places, right? That's very good because you are optimizing, right? It's all about optimizing. Then this is what required the major refactor. We decided to call the project as pooling. Basically, everything is built around the driver itinerary. The driver has an itinerary, and the goal is for the driver to not stop riding. So, picking up a package, dropping off that same package, picking up another package, picking another package from another client, delivering the second one picked up, and so on. So, as you can imagine, this is way, way more optimal. But this was not the original idea. So the database that we had couldn't match these new requirements. So this required a new database, probably even new technologies, because at the beginning we even were using PHP. So this also required backwards compatibility for the clients that were already integrated, which was quite complicated to handle. But for the courier side, we needed a new app, UI-wise, because before it was one pickup, one drop-off, pretty simple. But now it was like an infinite. It should be server-driven, so a new app was needed. And at that point, we had the app ready in Kotlin and Swift, but the backend team was still doing some changes in their site. So we said, okay, Flutter is around the corner. Why don't we give it a try? And we did that. So this is another high fidelity diagram of our tech stack. Everything is event-driven, right? So we have in Ruby the API. We have the dispatcher, which is the magic that optimizes the routes to pick up and drop off the packages. And then we have the direct connection to the API with WebSocket. Then we have the mobile app, and the mobile app is on the top right corner that you can read ARIDS. That stands for App Release Information Display System, which is basically a tool that we built so that we could roll out the driver application to different couriers in some specific zones. So it was not we had to do a stage rollout, right? Because it's a very long project. We have been working in this project for maybe 2 years, right? So we couldn't just change everything because probably everything would be broken. So you may wonder, why Flutter? Okay, the main reason is this one. We had time. If we didn't have time, it would be too risky. We were not sure if it was bug-free or not, so we really had time, so we could try. It didn't look like a hacker solution. It was not a web view. It was not Xamarin. It was not React Native, building widgets on top of it. So it's basically a video game, right? A white canvas, but instead of a mobile game, it's like widgets and everything focused on the mobile environment. That's also important. Lots of promises. Every blog that you can read about Flutter, it's all about how high performant it is, how easy it is to develop for it, many things. That's not so true, but we'll get into that. And something very interesting from a professional point of view is that who has Flutter experience? Probably no one, or the guys at Google, right? So if we take this technology right now, it means that in 5 years we'll have the most experience possible. So we really like that, and that's why we like that. So this is our application right now. Almost 99% of the code is in Flutter, which means that it's shared among Android and iOS. Then a small portion is on the iOS side and on the Android side. The reason for that is showing notifications. There are some libraries that you can use, but if you need fine-tuning, you better write it on yourself, or you do it and then you pull request. That would be the best option. We didn't do that yet, though. Accessing hardware, so the same thing. We require very specific GPS monitoring to track the driver's location. And the same, libraries were not good enough, so we decided to build ours. That's why we have more code in iOS and Android. Then we also have some kind of health check, battery level, volume level, the operating system permissions, some peculiarities that you cannot really deal with in Flutter, so you have to deal with them in the native code. And also third-party libraries, which, Segment, Intercom, Fabric, Crashlytics, whatever you can imagine, you need to initialize that in native code. So you choose Flutter. What's the first thing that you do? You write an article, right? That's the best thing that you can do. We wrote that article. It was called All In with Flutter. It got quite a lot of attention, but that attention came after we tweeted about it. We tweeted about it, and then Tim Smith, who's the Flutter product manager at Google, took a read at the article, sent us an email, and asked for a chat. He was very interested in understanding the issues that we were facing, if it was good, not what we felt was lacking. So we had a chat with him. It was Danny and myself. Danny is actually an iOS developer, so we had both visions, because I'm an Android developer, and then Lucky also joined us, and he was very willing to understand our issues. And we shared some of the issues, and he actually forwarded that to his team, and they fixed some of them, which is very good news. Something that we are also very happy about Google regarding Flutter is that whatever you open an issue in their GitHub project, they really answer. They really take care of those issues, even though some of them are not prioritized or sent to the backlog for December. Or actually, there's one very funny. I don't remember the name, but it's that's not gonna happen. But they have the bucket as well. They also review the code very quickly. We needed to do some pull requests, especially to the Google Maps plugin, and they really review it. They really share their concerns, and they merge it very quickly. We are very happy about that one. So now I will pass over to Pau, who will explain to you from Android to Flutter.
Thanks, Sergi. Well, the main things that we faced, we found moving from Android to Flutter. It's, for instance, the first thing is that we don't have to deal more with views. We have widgets, but the main difference is that widgets are immutable. You cannot mutate the widgets, so instead of what we are used on Android to change the state of a view, like you have a text view and you call set text and you change the state, on Flutter there is not possible anymore. So if you want to change the UI, you have to build a new widget. Like this. You have a build method and you return a new widget. But how update the UI when there are user interactions or responses or animations or these things? There are stateful widgets that have an attached state, and this state, this attached state can invoke anytime a build method. So a new widget is redrawn, So a new widget is created like this. For instance, he have it's a simplified version, but there is a button text. Here you can build the widget, a button that has this text, and when it's pressed, we call set state, and this makes Flutter to build again the widget, so it's built again. But this is it's super different to be used to work with changing a state, and this is a new paradigm. There is no XML anymore. It's only code. You build a tree of widgets, and each widget has a child, and so on. You get used very easy, so we find very comfortable with this working in this way, and the code is super easy to understand, so there is no problem with this. Another big thing is that there are no more intents. Working on the Android, the intents are a big pain in the ass, and using intents to open activities and fragments and parse data with bundles. With Flutter, there is no problem. There are routes. Routes are replacement of intents. A route basically builds a widget, and the widget that is built with a route is overlapped. It's drawn on top of the current widget that is displayed. Maybe it's on a screen or a dialog or anything. The routes are pushed and pop, and that's it. For instance, Flutter also take care of when the user taps on the back button to pop automatically the current route. And another interesting thing is that when you pop a route, you can return a result. And when you push the result, you can wait for a result asynchronously, because on Dart there are features, so it's like a promise on JavaScript. With this promise or this feature, you can wait and then receive a callback with the result, so you don't have to deal more with a start activity for result or similar things that are uncomfortable on Android. Background task. This is really problematic for us, because we need the application to be run continuously, even when it's in background, because we need to track the device locations and keep the connection with WebSockets to receive real-time notifications. And we faced two big problems with Flutter. The first problem is that back button destroys the Flutter activity, and Flutter activity is the one that's running Dart code. If the Dart code is not is stopped, then all connections are lost with WebSockets. But we find a way to overcome this, and discovered an unknown SDK for an Android method that is called move task to back. That what it does is moves activity to the task and back to the stack of tasks, and it displays the home screen. So it's for the user it's the same as pressing back button and see the activity disappear, but the activity keeps running, so the Dart code keeps running. But still, Android still can. There is another problem that Android, when needs more memory, maybe kills our process, or when the user opens the recent apps menu and removes the app, the Flutter activity is killed again. So in this situation, what we do is when we run a foreground service on Android, and when we monitor the Flutter activity, and when it's destroyed, we start another another Dart environment that runs on isolate, and we run on that environment just the functionality that we are interested, like tracking device location or connecting to WebSocket. Once the Flutter activity is open again, because the user opens again the Flutter activity, the application, we stop that service, that environment, and let pass to the More things. That is single thread. This means that we don't have to deal anymore with threads and concurrent programming with like in Java or Kotlin. It's an event loop that is similar to the main loop that we can find on Android. And you have operators like async and await. For example, in this case, when there is an I/O operation, here we are requesting data from some URL. The wait will suspend the execution of this code until the response is received. So it's super easy to program in this way because you don't have to deal with synchronization, and also there is no need for RxJava, and that comes with features and streams, and with a library that is called Stream Transform, you get everything that you have with RxJava. And another thing that I would like to add is that about the drawables, we just provide 1x, 2x, and 3x drawables for Android, and we didn't think too much on that, and it's working, and that's it. So for now, it's working, and that's it. Now I think that it's turn of Danny. Yes.
Well, hello, I'm Danny. I used to work as iOS engineer here at Stuart, but now I do Flutter too. So when thinking what we are going to share in this meetup, we decided to share three things: the good, the bad, and the things that we take away from our experience. So starting with the good, there's a really good feature of Flutter, which is the hot reload, which you can see exemplified in this GIF. We have Android and iOS simulators running at the same time. As you can see, the header is red, then we change to blue in code. You just save and hit R, and automatically, with recompiling or relaunching or installing the app, wow, it's blue. So that's coming from native iOS development, which is famous for being super slow compiling and installing. This is a huge time saver. So kudos to Google for providing this. Then the second cool thing is, hey mama, I'm making Android apps too, which for us seems like a difficult barrier. And with this thing, we can make some pretty decent apps. So we double the environments that we can program for. And also web is coming, so we're gonna be able to add a third environment more. And the third thing is that as Apple disclosed in last year's Worldwide Developers Conference, everything is moving to declarative programming, which is a different paradigm from imperative programming, which is what we were used to do. And this is like a first step to us in this different way of thinking how to program. So we're glad to learn different ways to do stuff. Also, we could get rid of Rx Swift, which is the library we used to program reactiveness, and well, we use subscriptions and things like that, like Pau said just a moment ago. So that's a big plus for us as well. What was not so good? We experienced several performance issues with Google Maps and effect views, which, if you're not familiar with, are this kind of cool blurs that many iOS apps have, that have like a blur on top of the background and then a shiny text on top of that. Even to the point that we end up using native views and with platform view show the native app, the native view on top of the Flutter view. Performance was not 100% like native for now. Maybe later we'll talk about it, but it's pretty good. So, well, could have been worse, could have been better. For us, and for us I mean the iOS guys, it's really tricky to debug because we are used to Xcode tools and instruments and the way to debug stuff for iOS. And we don't really find the same kind of support or features that we were used to have. So I think that's an area that this could be improved. And also, by looking at our metrics, we can see a significant amount of crashes related to Metal and OpenGL, which comes from Flutter, and we can't really fix unless we dive into Flutter itself and try to find to create a pull request or something like that. So, takeaways from this. It's a new paradigm for us, thanks to Dart, which we really love, by the way. Also, I'd say that maybe 98% of our UIs were made with storyboards and ships. So this is not happening in Dart. We have to declare the UI. And this GIF you can see here illustrates how we feel with our new IDE, because we were super comfortable with Xcode, but Android Studio or Visual Studio Code is like, okay, I'm gonna do this. Oh fuck, this is not the break. So, well, we're still working on this. And as Pau said a bit about threading, no more Grand Central Dispatch. So we move to isolate, and that's it for my part. So, Sergi or Victor?
Hello, I'm here again. And now I'm going to talk about our architecture in our app. First of all, we use MVP, that stands for Model View Presenter, as you know. Specifically, we use a variation that is passive view variation. That this means that the view is completely dumb. So we try to the view to do the less thing as possible and move and have all the logic on the presenter. And it's the presenter that sorry. And it's the presenter that basically give orders to the view, super clear orders. And the view communicates with the presenter through events. There are, when you check documentation of Flutter, and ways to separate the view and the logic of and the there a lot of times there is people use block. What? But for us, we prefer MVP because it's easier to test. You can easily unit test the presenter, because you only have to mock the view with any tool to mock. And also it's super easy to understand what presenter does when you check the view that is an interface. We are going to see an example here. This, for instance, in this case, we have some view that is an interface, and there are two methods. And just checking this interface, you know that the presenter will show some text and eventually will hide some parts of the UI. Then implement the presenter. It's like super easy. Just get in the constructor the view. Then offer some life cycle methods to start and stop the presenter and dispose to clear resources. And expose some methods for the view to communicate and send events. And we implement the view in the state. We use stateful widgets, and we implement the interface of the view in the state. When the widget inits the state, when the widget is initialized, We create the presenter, start the presenter, and we stop the presenter. And when the presenter calls some view methods, like show some text, we change the state and update the UI. After that, we do magic with repositories. We use extensively repository pattern, and with this we don't need to use Redux or MobX. That these are tools or techniques that are used to control the global state of Flutter applications. With this we also have a reactive programming model using repositories, because repositories can return a stream, and then the presenter can listen to a data stream and react to model changes and update the UI. So we still have reactive programming. The concept is simple. Each repository has an interface. We try to have a specific implementations of that interface of the repositories. We try that each implementation has a single responsibility. Like for instance, you have a repository to get whatever something, then we can have an API, the implementation that deals with the API. Then another implementation that catch that model. Then another implementation that receive updates of that model, and then and returns that models that updates through the stream. And then we connect these repositories like a pipeline that is a chain of repository implementations, and each one does his job and delegates, if it's necessary, to the next one in the chain. And all of this is injected using a dependency injector to our presenters. And we found a solution. We made our homemade dependency injector, dependency container. So we find that we don't need any more Dagger or any dependency containers that are outside. And this is it. If you want to check a little more about our architecture and how we work, you can check our engineering blog at Medium. And now Sergi. Yeah.
So thank you, Pau. So performance issues. I spoke a little bit about it. Danny did as well at the beginning. Whatever they said that Flutter is a very high performance framework, that's not true. It's very complicated to deliver 60 frames per second. There are some devices which actually run on 90 or 120 frames per second, so I cannot imagine. We recently bought some pixels. We didn't have them yet, so we'll see. But on Pixel 2, we usually deliver 60 frames per second, but if you take any other Samsung low to medium range, not really. We really struggle. It's around 40 frames per second. So the app is smooth, but not as smooth as we would expect. And we don't know what to touch. The app is not as smooth as we would like to, but we don't really know what to do. We don't really know what to check. There are a lot of documentation that was recently added on the Flutter docs. But we are not there yet. We're focused on releasing the application. We'll get into that soon. But yeah, we are pretty lost. So if you have any tips, please share with us. Something very important that we needed to fix quite a bit, as I said before, it's the Google Maps. It's not built in Flutter, so it's basically a bridge that shows a native view. So it's actually a Kotlin or Swift code. And that bridge really slows things down. Also the plugin, which is the bridge, was also lacking a lot of methods. It was not performance enough. it was doing some crazy things. So we had to do some pull request on the repository. And yeah, what I told you, we don't really know what to do. So really help us. You can even try that. Just take the Flutter source code, the Flutter. You create a brand new project. You add a white canvas, so you don't add anything. You open a drawer menu. You press the button to open the menu, and then you see like 2 faces, and it's mind blowing. The rest is fine, but if we cannot even open a menu on 60 frames, we are quite sad. Something else, the framework changes a lot. Like there are a lot of commits every day. They have a lot of channels, so we are always on the Vita channel because the stable one is not, let's say, fast enough. Their cycle is so slow. So we are on Vita, and being on Vita means that you get a lot of regressions and many other crazy things. So this is a report from Fabric, from Crashlytics, that from the top 5 issues, the fourth one, the first, the second, the third, and the fourth are actually not under our control. We saw that it was reported, the first and the second and the fourth. Actually, no, it's 6. 6. So yeah, the 5 ones, we don't have any control. We were able to patch the first one by changing their source code in a hacky way. So we got rid of that first crash very recently, but we still have the other ones. There's not much that we can do. We are very hand-tied. What I told you before, Google Maps is not written in Flutter. It's a bridge, so it feels like it's a web view. So the performance doesn't look good enough. At the beginning, we couldn't even draw polygons nor polylines, so it was just a map. And what do you do with a map? Nothing. You want to add pins, you want to add routes, and we had to implement it. It was not complicated, though, because adding that into the source code is very easy. And as I said, they are very fast on reviewing the code and approving the pull request, which is awesome. So that was not really a blocker. Pau also did a pull request that fixed a lot of performance issues. So that was very good. Now I will try to show you, if that works, a small demo of the current application. This is Flutter. We are not lying. So you would log in. Hold on, it takes a while. You won't see my password. So this is the permissions for the GPS. You would go online, you would accept the GDPR. Sorry, it's very quick, but we have alert because the volume is so low. These are the device health checks that I told you before. Now we will receive an invitation for a delivery that says that you have to pick up something on Carrer de Pau Clarís 180. So you'd accept that delivery. Then that's the first step. You go to the pickup place. Here you see the details of the client that ordered that. Then you can check the full details of the package, the origin and the destination. So you complete the pickup. Now the server tells you, okay, go to the drop-off, which is the same place. This is a mock. And then you would say, okay, I have dropped the package. So you have to provide a signature. You have to provide like a confirmation that you did the drop-off. So a signature, that's it. You complete the drop-off, and then you are done on that job. So you see the earnings increasing with some animations, then you go offline. We have another part of the application, which is the deliveries view, where you can see basically how much you have been earning recently. You have a calendar that you can navigate through. You can see the details of every delivery. And then we also have, which I think that's the coolest UI part of the app, which is the work log. Like everything is tracked. The money you earned, the time you've been online. So this is the most beautiful part of the app. It's true though that we don't have fancy animations, but remember that this application is meant for couriers that are on the street, so they don't really care about the animations. They want things to happen as fast as possible. So the less animations for them, the better. But we need to keep a balance between being smooth and not being like junky. So now the QA team will explain to you their experience in testing Flutter applications. So Victor, please.
So, hello everyone. Is there any QA in the room? Okay, the ones I have worked with. Cool. So for us, for the QA team also, it was like a challenge because we didn't know how Flutter was going to perform, actually. It was new as well. At the end, manual testing wasn't that different from an application because at the end it's a native application. We found the same issues as anyone could found in any application. And the only thing we should only really care about is when they do some specific code, like for example, for the location and so on. So we need to test it twice. For the other things, it's quite nice because we don't even need to test on both platforms. It's just testing on Android or on iOS or on the phone that we have on our desktop. So it's okay. And now talking about the test automation, I don't know if you have give a try to, well, we used to have a XUI test for iOS and we ran our test on Espresso. The framework didn't seem to be that mature at the moment because we didn't saw many people doing it, many activity that since the mobile team was going to do it in Flutter, we had to give a try. And we found 3 testing approaches. That it's the unit test, which I'm not going to talk about because I leave it for you guys. The widget test, which we gave a try because they seem to be quite easy to do. And also the integration tests that they call that are for us the UI test. So talking about the widget test, we are testing a single widget in isolation. We don't test anything else. We create the widget in the same test. We pass whatever we want. They are super fast. They take seconds, literally, and are super reliable. I didn't saw any test that any widget test that failed at the moment, which is good. All the dependencies have to be mocked. We can use the application code, for instance, all the repositories that they had, all the entities, like for example, I'm going to show you another one. That it's a driver. We had a test that was mocking like a driver that is validated in a screen, so we can say, hey, you can work, and this can be done with Mockito. That is the framework we use for to mock stuff, and that's it. It seems to be for us quite easy, quite reliable, and we are happy with them. We don't have many tests, but at the moment they are working fine. And the thing we paid more attention and we put more effort on it was the UI test, because it's what we are more used to do in native apps. Some great things that they are quite robust at the end. We don't have that much false positives as we had with Espresso, for example. We didn't have to deal with any weird situation with flaggy tests. Another thing that is quite good is that there are 2 isolates, that is the app code running and the test code running, which for us it's fine and let us like separate the things. We were using the page object pattern like in every other project we did, like for Espresso and XUI test, so the learning curve wasn't that hard. About the Flutter driver API, that it's the driver that interacts with the application. At the moment it's quite okay. Everything we can do, it's super easy, like tapping, writing text, doing swipes. We didn't found any challenge. And also, as Pau said, the features are amazing. It removes a lot of code, like wait for it, do that. You just have to put an await. At the very beginning, it was quite hard to get used to that because I always was forgetting to put the await keyword. So everything was crashing. I remember Pau helping me quite a lot. And there are some other things that didn't went that well. Well, at the end, they went well, but they were quite hard to come. We were used to Mockito for mocking everything in the tests that we had running for Android with Espresso. Mockito couldn't be used really straightforward for our test. I remember I did the very first pull request. I was so happy, like, hey, this seemed to be like the very same. And when I click on run, it boom, it doesn't even build. And that's why we had to find a way. I'm not going to talk about that. We already wrote some articles on Medium on our engineering blog. So if you want to have a look about how we did, you can go there. Also, some other things, it's to run the test in Flutter, you have to run the isolate itself. So you have, we separate each test for screens. So each screen is a test class. And at the very beginning, it was quite challenging because we had just to run one command to run them all. And it wasn't easy, but at the end, we created each class is like a method where we execute in the main thread of the isolate of the test. And also another thing, it's the reset application that the mobile guys did some trick to recreate the activity from scratch from the beginning of the app. Another things are dealing with concurrent builds because they are 4 developers. Well, now they are 6. We are 5 in the QA team that can write code, and only one single Flutter command can be executed at once. As soon as you execute one Flutter command, you have to wait for it to be released. So you can imagine if there are like 3 or 4 concurrent builds, it can take, I don't know, 1 hour, no, more or less, for the last one. And we managed to overcome that with a really hacky solution that it's duplicating the folders of Flutter. So we have a lot of Flutters, and well, at the moment it's working quite fine. And also debugging the test. There's a way to debug them because you start the Dart virtual service or whatever it's called. I don't remember right now. And you can attach it to the process of the Android Studio, and you can do it like debug the isolate and of the test and the one of the application. And to end, I'm going to show you a video. Okay, so this is like a test executing in an emulator that we execute our test in our build server, that it's a Mac Pro that we have. And they run on emulators. We don't use real devices. And at the end, it's like building the application, installing the app. And you can see now, like, we have a lot of debug logs. We are emoji driven in Stuart, by the way. And that's it. I'm going to pass to Sergi to the conclusions.
So we are reaching the end of the Flutter presentation. So I'd say it's been a success. There was a moment in which we had more code in Flutter than in the native approach. At the beginning, remember that I told you that we had the application ready in Kotlin and Swift, but then we went all in with Flutter. But there is a point in the project that you actually have to choose. Either you go with this one or the other. And we said, okay, yeah, all in with Flutter. And when you do that, you have a lot of risks. And we are happy. Nothing exploded. We are still there. We're still here. So yeah, we can say it's been a success. Something very important is that potentially we doubled the resources and halved the bugs. On the resources, not really. I'd say we halved the resources because we are still learning, so we are still slow. But eventually we'll be able to be as fast or faster than we were with the with the regular Kotlin Swift approach. And half the bugs, that we are already feeling it. The other day, for instance, on the WebSocket library that we use, we found that it had a bug, and on the 54th retry of reconnection, it didn't try anymore. And we're like, why 54? And then we tried again, it failed on the 57. We're like, what? And we found out that the library was using a backoff, doing some crazy wrong maths, and it was ending up comparing an infinite with an infinite double in minor, I don't know, something crazy. And the good thing is that the bug happened on both platforms. So the question of, is it happening on Android? Is it happening on iOS? That's not happening anymore. It's there's a bug and we fix it, or anyone can take it and we fix it once and boom, it's fixed. As I told you before, whatever the Flutter team delivers, if it's a bug or a feature, we eat it. We are on the beta branch, so even worse, we could be on the dev branch, which would be crazy. So we are in the middle, and we don't think that we would use it for the client application. I didn't mention that before, but we have a client application which is where you order Stuart. They said that you can use Flutter partially. So imagine, I don't know, you have like the help center and you build that with Flutter and the rest with native code. Yeah, you could do that. But the moment you need to share models, to share authentication, networking, no, it doesn't really work. So you either go all in or you don't do anything at all. Yeah, that's what I just said. I think every one of the speakers said the same, that we really love Dart. And it's not that we all are aligned on adding that into presentation. We really feel like that language is, I mean, today I was speaking with Pau and I told him, I think it's the best language I've worked with so far. It's pretty good. And the last thing, which makes me very happy, is that Flutter is what made us meet today here. So thank you for coming, and thank you. Yeah. So in 3 minutes we should be eating. So you better go fast on the Q&As. Yeah. JVM or Swift code. For those that are hearing this but couldn't hear the question, yeah, basically what he's saying is that maybe the performance issue is on the communication with the native part, right? That could be one of the reasons. We didn't profile the app yet, and maybe that's the thing. But what I'm afraid of is that that's never going to change unless they improve the communication channel. But we'll always need to communicate with the native code, because Flutter doesn't do that for us. We need to call the, let's say, the electronics, right? And that's only doable by calling the native. Yeah, maybe that's a good way to start checking like that part. Yeah. Thank you so much. Any other questions? Yeah, over there. That one first. Yeah.
Thanks. So when you start looking for solutions, and you decided for Flutter, you said that it was pretty different than React Native. Because I thought that it was pretty similar, and so for you, what are the main differences between both, and why at the end you choose Flutter over React Native?
So React Native has been here for a very long time already, and the feeling that I personally have with React Native, it's that it's somehow hacking the platform. So it's a framework that it ends up building things on another framework, right? The Flutter approach was like a video game. It's just a white canvas, and everything very already prepared to have like the toolbar, the side menu. So the reason why we didn't go with the React Native is that we didn't feel. It's very hard to answer that question. But let's say that Flutter somehow was different from React Native, like the concept, like white canvas and you draw every pixel on the screen and you have full control of every pixel on the screen. On React Native, it's very easy and fast to build an application, a material application, but the moment you want to add to customize some widgets and so on, it can become way more complex. So that's more or less why.
Hello. I'm curious about, did you have any issues with working with the navigator, in the app? Maybe having some recursive, yeah, that's one case. Yeah. And the other one is, did you have any issues like building the flavors and configuring, the app? And package and all that.
So the first one, you spoke about navigations. Pau spoke about before on Android we had intents, now we have routes, right? Yes, and I have been recently speaking with the team because this is something that we don't really understand. So imagine you have 3 widgets, one on top of each other, but them can show up asynchronously. All you can say is pop. Whatever is on top, you cross your fingers very hard because whatever is on top will be popped, and that caused some bugs. Because, for instance, as you saw on the demo, there was like a too low volume alert, and that there was like a race condition where this was on top of the invitation or actually beneath the invitation. Something crazy, but when you pressed accept, it didn't work because it was actually popping the volume. So you can imagine a courier pressing the accept button and it's actually dismissing the low volume alert. Yes, this is wrong. We don't really understand why it's done this way, but we need to find a way to fix it because that's really a pain. The second question was about working flavors. Yes. So we defined several environments. We didn't speak about it, and maybe that's a very interesting topic. We have 3 environments in Stuart, more or less, that we use in the mobile app, and we define them on a single class. That when you run the application, you can specify. I think it's called target. So you basically specify which runner you use. So for every environment, we have a runner. And that runner configures everything. They basically changes the API, the tokens of but we use different runners for different environments. We didn't want to go for the flavor or the iOS one, which I don't know the name, how you customize targets. Yeah. We wanted to have something way more generic. We wanted to go away from the native part. It's either you really focus on doing one single code base, or you start having things spread all over the code and it's a mess. So we really and it really works. That would be worth sharing. Maybe we could even write a small article about it because we found that approach and it really works well. Because we have some other different environments, like when you run tests, there are some things that you don't want to test. I know you don't want to check for if the device has a low battery or not because it's a device. So this kind of configurations, we managed to deal with that. Yeah. Any other question?
Okay, so since you talked at the beginning of hot reload, so my question is, now that you have like a big app working with that, did you face any kind of not so hot reload, or, because at the beginning when you try it, it's like, whoa, it's crazy, it works really well. But when you have like a full app, is it also performing that well?
It does. And it does, I think, because of the app architecture. So when the hot reload, all the hot reload does is like uploading the code, but all it will change is the UI. Everything that is not on the UI, you better press a full stop and play, right? On Android, we also had this hot reload feature, and I felt this thing that none of my projects were able to be hot reloaded because you have the context probably in a hacky way. You do probably we did things in the wrong way, but it's true that with Dart, everything that is UI, you can press hot reload, it really works. But if you want to change network calls and so on, you better press stop and play again. It's true though that even if you do a full start, it's very quick. It's very, very quick. It takes. We have powerful iMacs, so I don't really know about laptop, but it takes like 10 seconds to run the app. So it's not that bad. On Android, I remember that a full compilation took like 3-4 minutes, which you can imagine it's a pain in the ass, especially when you switch between flavors because everything's recompiled and then something is missing, something. So yeah, quite a good experience so far with hot reload. Anyone else? Okay, so that's it. Thank you for coming again.